And good morning, everybody. This is going to be your notes and examples on learning how to factor quadratic expressions where the lead coefficient is 1. And a quadratic expression is an expression where the power or the degree on the variable, the highest degree, is going to be a power of 2. So they come in the form ax squared plus bx plus c. So the highest power for a quadratic expression is going to be a power of 2. Kind of similar to a linear expression. So you have studied linear expressions. So y equals mx plus b. So a quadratic expression would come in this form. A linear expression can be written in this form. And if you look at the powers on the variables, so the highest power on the quadratic is a power of 2. And the power on a linear expression is a power of 1. So if the highest power is a power of 1 on the variable, then it's linear. And if the highest power is 2, then we call that a quadratic. So for this, we're going to be learning how to write our quadratic expressions in a factored form. And before we do any examples, let's just kind of talk about the two different forms of a quadratic expression. So let's say we started out with two binomials. So let's say we had x plus 3 being multiplied against x plus 4. So in some earlier modules, you were practicing multiplying these two factors together. What we're going to do in this module is actually go in the opposite direction and take it from the multiplied form and bring it back to the factored form. So if I were to multiply these together, x times x is x squared. X times the 4 is 4x. And then distribute your 3. 3 times x should be 3x. And 3 times the 4 will get you 12. And then if you combine your like terms in the middle, you have x squared. The 4x and the 3x, we can combine those and say this is 7x. And then the last term is a 12. So what we basically have here is two different forms of the same expression. So the top form, the one that we started with, we would call this the factored form. So this would be the factored form because it's expressed as two factors being multiplied against each other. The first factor is the x plus 3. And the second factor is the x plus 4. And if you multiply these two factors together, then you get the general form or the standard form. So when we multiply those together, we produce this, which is the standard form. So what we're going to be working on today is going from the standard form back to a factored form. And where we're eventually going to go with this is we're going to end up using our factored form when we get into equation solving. We're going to end up wanting to have the factored form so we can solve the equations by setting them equal to 0, but that's going to be a lesson for a different day. Right now we're just going to work on how do we get from the standard form and bring it back to its factored form. So let's go ahead and look at something that's in its standard form and see if we can bring it back to what its original factors were. So let's clear this. And let's say we start with the equation x squared plus 9x plus 20. And we know this is going to come from two things being multiplied together. So some of them are pretty obvious. Some of them you need to kind of slow down and think about a little bit. So the first one, how do we make x squared? So x squared, you're going to need to have an x multiplied against an x. So we're going to need an x times an x. That's going to get us the x squared. So if we were to kind of think about what's happening when you're distributing or multiplying together, x times x is making the x squared. And then if you kind of skip ahead to the back term, we need something here and here that when we multiply them together, you get the number 20. So we need kind of two numbers right here that when you multiply it together, you get the number 20. So there's going to be a few options when you multiply this together to get 20. So how can we multiply some numbers together? So let's make a list of possibilities. So we want to multiply things together to get 20. So we know 1 times 20 is going to make you 20. We also know that 2 times 10 can make a value of 20. And we also know that 4 times 5 can make a value of 20. So the next question is, well, which one's the right combination? And to figure out the right combination, you need to look at your middle term. So when this goes through the multiplying process, yes, these two numbers on the end need to make 20 when you multiply, but they also need to come together and make the middle term 9x in the middle. So you're looking for two numbers that multiply to be 20, but they're going to have to add up to be the number 9 in the middle. So out of these three possibilities, which one adds up to be 9? So if you look at this one just adds up to be 21. So that's not going to work. This one adds up to be 12. So that won't work. And notice this combination adds up to be 9. So this is going to be the right choice. So we're going to need to put a 4 and a 5 in for those last two terms in each binomial. So it's going to be a 4 and a 5. And then you're going to need a positive 20 when you multiply. So you can't have any negatives involved, because if you have a negative and a positive, that's going to make you negative 20. So you're going to need a positive and a positive. I guess you could have two negatives. Negative times negative would make a positive 20, but that's going to get you negative on the middle term. So they're going to want to be positive. So that's going to be your factored form. And to check your factors, all you simply need to do is multiply them back together and see if they work. So to check it, which I would recommend you do, just distribute everything together. So if you do x times x, you should get x squared. If you do x times 5, you should get 5x. If you do 4 times x, you should get 4x. And if you do 4 times the 5, you should get the 20 that we were looking for. So notice the 4 and the 5 are making that value of 20 that we wanted. But at the same time, they're combining in the middle to make the 9x that we were looking for. So that's why we're looking for factors of 20 that add up to be 9. So if you simplify those two middle terms, you should get your standard form back, x squared plus 9x plus 20. So that would be a check to check your work. So the answer is right here in the green box. That is your factored form, 2 parentheses, x plus 4, x plus 5. So let's go ahead and do another example with not quite as much explanation behind it. Let's just kind of walk through the process. Okay, so without all the explanation, here's basically what you're looking for. You're looking for things that multiply to be the back number, but add up to be the middle number. So to organize your values, you can do a chart. We're looking for something that multiplies to be 6, positive 6, but it's going to add up to be 5 on that middle term. So what kind of numbers multiply to be 6? You could have a 1 times a 6, but if you add those up you get 7. You could have a 2 times a 3. If you add those up you get 5. So it looks like that's going to be our two options that are going to work. So to factor this, what makes the x squared? You need an x multiplied against an x. And what makes the 6? You need a 2 and a 3. Doesn't really matter which order you put those in. It can be the 3 and then the 2, or the 2 and the 3. They're both going to make 6 when you multiply. And it needs to be positive 6 when it multiplies and positive 5 when you add. So you're going to want positive on both of those. And that's going to be your answer. That's your factored form of that original standard form. And I would always recommend that you check it, even if you just check it mentally. After you've done a few of these, you can kind of check them mentally. But if you go ahead and multiply everything together, x times x is x squared. X distributed against the 3 is 3x. 2 times the x is 2x. And 2 times the 3 should get you 6. And those two middle terms combine for that 5x that we were looking for. So we get x squared plus the original 5x in the middle plus the 6. So that checks out. That should be a good factored form. So again, the answer we're looking for is this factored form that is right here. A binomial times a binomial that makes that original expression. Alright, so let's go ahead and do a few examples from the IXL.com. So here's our first one. They're using variable j, but again, no different than just having an x there. So we need two things that multiply to be that original statement. So how do we get j squared? That would have to be j times j. How do we get 20 on the back? So you need numbers that multiply out to be 20, but they're going to add up to be 9 in the middle. So when the numbers are small, you might not make the chart because you can maybe do it in your head. When the numbers get bigger, you might want the chart so you can list out all your possibilities. So we're looking for things that multiply to be 20, but add up to be 9. So you might jump right to the answer, which is 4 times 5, which is going to make you 9 when you add. So we're going to need a 4 and a 5 to make the 20. So the 4 and the 5 are making the 20. But notice if you look at your other multiplying, 4 times j is 4j, and this is 5j, which is making 9j in the middle. So your factors are right here. You want to type that into the answer box. So in the answer box, you want to put parentheses j plus 4, and then parentheses j plus 5. And again, until you get the hang of it, don't be afraid to actually multiply it back together on paper, since it's all kind of new, and see if it really works. So if you did distribute everything together, j times j is the j squared. J times the 5 is your 5j. 4 distributed in is your 4j. And 4 times the 5 is a 20. And then your two middle terms make that 9j in the middle. So that's going to get you your j squared plus 9j plus 20, which is what we were trying to originally factor. And here's another one. So we need two things that multiply together to make the original statement. So we need a z and a z to make z squared. And then we need two numbers that multiply to be 14 but add up to be 9. So 2 and 7 will make the 14. And if they're both positive, you're going to get 2z and 7z to make that 9z that you're looking for in the middle there. So those would be your two factors. So you're going to put this in the answer box. So again, the big idea, you're looking for factors of the back number that add up to be the middle number, if you had to summarize this. The next one, we need something that multiplies to be the back number, but adds up to be 5. So you could put a 2 and a 2 there, but notice if you kind of think about it, you're going to get 2q times 2q, which gets you 4q, which is not what we're looking for. We're looking for 5q. So this would be an example where 2 times 2 doesn't work, but what else can multiply to make 4? So sometimes it's trial and error. You just got to think of the numbers. So 2 times 2 makes 4, but 4 times 1 also makes 4. And that's going to get us our 5q, because when we distribute these two values, that's going to get you 5q, and that's going to get you 1q for the 5q in the middle that you're looking for. So those are going to be your correct factors. That if you multiply this together, you get q squared plus 4q plus 1q plus 4, and then there's the 5q in the middle that you were looking for. And let's look at this one. N times n will make the n squared. We need factors of 5, so our choices are 5 times 1 or 2 times 3. So if we try the 5 and the 1, that's going to get us 5n and 1n to make the 6n in the middle. So that's going to be our factorization for this one. And here's another one. We do have some negatives in here now, so we got to watch out for our plus and minus signs. Same idea. We're looking for factors of negative 11 this time that multiply to be negative, or add, excuse me, to be negative 10. So they multiply to be negative 11, but they add to be negative 10. So the p and the p is obvious. P times p is the p squared. So what kind of numbers can we multiply to get negative 11? The only factors of 11 are really 1 and 11. But if I do a positive 1 times a positive 11, that's going to get you positive 11. We need a negative 11. So one of these two numbers has to be negative. Either it needs to be a negative 1 or it needs to be a negative 11. But remember, we're trying to add to be negative 10. So you're going to end up with more negative value when you add. So we're going to want to give the negative to the 11 so that when you add those up, you get negative 10. So the correct numbers are going to be positive 1 and negative 11. And as always, if we think this is the answer, p plus 1 and p minus 11, multiply it together and see if it actually works. So if we distribute the p, we get p squared. If we distribute the p to the next term, we get negative 11p. Distribute the 1, and we get 1p. So 1 times p. And the number times the number should get you negative 11. And if you combine your like terms in the middle, you get p squared. Negative 11p and positive 1p is negative 10p that we were supposed to have in the middle, and then negative 11 for the last one. So that does check out. So these would be your two factors. And here's another example that has some different signs, plus and minus signs. So the v squared, you're going to need v times v. We're going to be looking for things that multiply to be the back number. So they need to multiply to be negative 2. But they need to add to be positive 1v in the middle. So they need to add to be positive 1. So factors of 2 are just 2 and 1. And where does the negative sign need to go? We need either a negative 2 or a negative 1 to get negative 2 when you multiply. But we need positive 1 when we add. So we need more positive than we do negative. So we're going to give the negative to the smaller number. So when you add these up, you get positive 1 when you add them, which is what we're looking for. So the numbers you're looking for are a positive 2 and a negative 1. Negative 1. And again, check it by remultiplying even if you do it mentally. So v times v is v squared. V times the negative 1 is negative 1v. 2 times the v is 2v. And 2 times the negative 1 is negative 2. And if you simplify your two middle terms, you get v squared plus 1v minus 2, which is what we were looking for. So that checks out. And this should be your answer that's going into the answer box. And let's do one more where we have some minus signs involved. So u squared, you would need a u times a u. We need something that multiplies to be 19. So probably 19 and 1. And notice on the middle term, you need more negative than positive, so we're going to give the negative to the bigger number, and then positive to the other number. So when you multiply the negative 19 and the positive 1, you produce the negative 19 that you need, but when you add them up, negative 19 and positive 1, you get the negative 18. So those should be your two factors. And again, check out by multiplying. So u squared, positive 1u, negative 19u, and negative 19. If you combine your two middle terms, you get negative 18u minus 19, and that checks out. So this answer should go into the answer box. So that's all the notes and examples. The big idea, if you wanted to write down a big idea for this, you're looking for things that multiply to be the back number. So they need to multiply. So you need factors of the back number. That multiply factors of the back number that add. So this is the multiplying. So finding two numbers that multiply to be the back number that add to the middle number. If you want a summary of what you're basically doing. So two numbers that multiply to be the back number, but you're going to add them up and get the middle number.